The operational effectiveness of any fighting force, particularly an air force, largely depends on the skill of its available manpower, as well as the availability of required platforms and equipment. In the Air Force, the most critical platforms are usually fighter aircraft and other aircraft types, all of which require several ground support equipment for operation and maintenance. There are also other support equipment which might not be directly related to aircraft but are needed for an air force to function. Another critical requirement for the sustenance of air operation is adequate and timely supply of aircraft spares. In a nutshell, the Air Force is a highly technological dependent force, and consequently, any Air Force that aspires to be operationally effective must be conscious of technological evolution and must always seek the means to keep abreast. The current Nigerian Air Force leadership, under the Chief of the Air Staff, Air Marshal Sadique Abubakar, being mindful of the foregoing, has focused on innovation through sustained research and development efforts as a way of enhancing its operational effectiveness. After his appointment as the Chief of the Air Staff on the 13th of July 2015, the vision revealed by Air Marshal Sadique Abubakar to increase professionalism in the service left no one in doubt as to what to expect. Two pertinent key drivers of his vision are the establishment of strategic partnership with ministries, departments, and agencies for enhanced research and development, and to reinforce a culture of self-reliance and prudent management of resources. Since then, the Nigerian Air Force has taken significant steps aimed at deepening research and development in the Nigerian Air Force. The first major step taken to further enrich Nigerian Air Force research and development capability was the establishment of the Air Force Research and Development Center in October 2015. This was aimed at pulling all the Nigerian Air Force postgraduate degree holders in the aerospace vehicle design and related fields together to form the nucleus of Nigerian Air Force research activities, following which the 19 PhD and over 60 master's degree holders were given the necessary mandate. The second step was the signing of the Memoranda of Understanding with selected universities, polytechnics, and other research agencies based on needs and identified capabilities. The tremendous work achieved by the Air Force Research and Development Center has further led to the establishment in March 2018 of a separate center, the Central Avionics Overhaul and Calibration Center for research into avionics and aircraft electricals and instruments. Another major step was the reinvigoration of the annual Nigerian Air Force Inter-Command Research and Development Competition and Exhibition. The event is aimed at encouraging field units to showcase their research and development efforts to a wider audience, while also exposing them to efforts of other exhibitors, which include universities, research institutes, and local companies involved in research and development. As a result of these foregoing steps, the Nigerian Air Force has recorded quite a number of research and development feats since July 2015, some of which this short documentary highlights. One of the major research and development breakthroughs has been the production of the first indigenous operational unmanned aerial vehicle named Segumi. The Segumi was designed and developed by the Nigerian Air Force following the success of the prototype UAV named Gulma. The Segumi was inducted into the service by the President Muhammadu Buhari on 15th of February 2018. It was designed in collaboration with UA Vision of Portugal and could be used for applications such as intelligence surveillance and reconnaissance, policing operations, disaster management, maritime patrol and pipeline monitoring, among others. The Nigerian Air Force has also designed and developed a trainer UAV named Mugen. The Mugen is used for training of Nigerian Air Force remotely piloted aircraft operators at the 401 Flying Training School, Kaduna. The Nigerian Air Force also received the Patents Right Certificate for the production of the hydraulic accumulation diaphragm for the Mi-35 helicopter gunship in September 2016. The hydraulic accumulation diaphragm is a very important component of the Mi-35 helicopter, which is one of the main combat platforms being employed in the Northeast. Aside from being very expensive, the diaphragm was scarce to source, and yet it required frequent replacement to assure safe flying operations. In collaboration with some mechanical and rubber technologies outfit in Nigeria, such as Desotec Nigeria Limited, Port Harcourt, Iolat Nigeria Limited, Ibadan, NFX Rubber Factory, Oluyele, Ibadan, and National Engineering Design Development Institute, Nnewi. The research efforts of the Nigerian Air Force, led by Air Commodore A.O. Emafido, had resulted in the production of a more durable and much less expensive one from that of the original equipment manufacturer. The Nigerian Air Force was procuring each diaphragm from overseas at about $18,000. But the one for which the Nigerian Air Force had received patents right cost 25,000 naira, equivalent of $70 only. Air Commodore A.O. Emafido, who is one of the directors at the Air Force Research and Development Center, also conducted research that led to the in-house repairs of a total of 8 radio altimeters of Nigerian Air Force Alpha Jet aircraft, C-130 Hercules aircraft, and ATR-42 maritime patrol aircraft, as well as the repairs of 2 ultra-high frequency and very high frequency radio of the Alpha Jet aircraft. The average unit price of the items repaired is $10,000. Hence, it would have cost the Nigerian Air Force about $100,000, that is about 36 million naira, to replace the 10 altimeters and radios that were repaired in-house through research and development efforts. While repairing the radio altimeter, it was realized that lack of constant power supply posed a great challenge, as ground power units are electrically powered. Therefore, to sustain the in-house maintenance of aircraft's avionics and electrical models, the Air Force Research and Development Center, in collaboration with the Electrical Development Institute (OCA) and Desotec Nigeria Limited, Port Harcourt, conducted research that led to the production of a prototype multipurpose power supply that cuts across various power needs in the aviation industry. The 3-in-1 aviation power pack, named SB Abubakar Aviation Power Pack, is powered by cascaded batteries to produce 115 volts alternating current and 26 volts alternating current at 400 Hz, as well as 28 volt direct current. It takes input power from mains power supply, as well as integrated solar panels that charge the batteries for sustained operation when operated in forward operating bases. Aside from being useful for the testing and repair of equipment in avionics, electrical and instrument workshop, the SB Abubakar Aviation Park could be used as a ground power unit to start aircraft and conduct ground checks. The power pack was produced at a cost of 850,000 naira, whereas similar power packs that are imported from abroad cost about 23 million naira. Another significant feat was the reactivation of the communication control unit of the trainer version of the F-7NI fighter aircraft. The failure of the CCU, which enables instructor pilots and trainees to communicate with each other and the control tower while on training missions, had resulted in the grounding of the aircraft, thereby hindering training of fighter pilots. Ordinarily, the communication control unit cost about $40,000, about 14 million naira, and would require a minimum of 10 months to deliver to the Nigerian Air Force. However, through the ingenuity and resourcefulness of Nigerian Air Force engineers and technicians at the Central Avionics Overhaul and Calibration Center, 440 communications control units were repaired locally in a record time of just 1 week at a cost of only 400,000 naira, thus saving the nation about 57.6 million naira. More importantly, the expeditious in-house reactivation ensured the continuation of fighter pilot training, thereby enhancing Nigerian Air Force operational effectiveness. In a similar vein, some multifunction display system for the Augusta 109 helicopter, which has shown persistent failure after few years of use, were equally repaired in-house. A total of 5 multifunction display systems were successfully repaired. 3 have been tested on a helicopter and certified serviceable. Central Avionics Overhaul and Calibration Center is in the process of updating the software of the remaining 2 multifunction display systems. For the 3 multifunction display systems already returned to service, the Nigerian Air Force has saved a sum of 164 million naira for the nation. An additional 108 million naira would have been saved when the remaining 2 multifunction display systems are returned to service. In addition, the Central Avionics Overhaul and Calibration Center has successfully repaired 3 electronics horizontal situation indicator and electronics altitude director indicator for the ATR-42 maritime patrol aircraft by building a mini test bench to test them and subsequently carrying out component-level repairs on unserviceable cards and replacing components found to be faulty, which are now operating optimally. The in-house repairs of the 340 onboard aircraft indicators have saved the nation a total of 21.6 million naira. A similar feat was recorded by the engineering wing of 101 Air Defense Group Makurdi, where the old unserviceable cattle ray tube rear cockpit head-up display of the F-7NI aircraft was replaced with a modern liquid crystal display head-up display at the cost of 300,000 naira as against 200,000 US dollars, which is about 72 million naira, that would have been required to procure the same unit from abroad. Another benefit of the research and development efforts of the Nigerian Air Force is the design and manufacturing of a test bench for the Alpha Jet aircraft anti-skid system. The anti-skid system is critical to the braking of the aircraft after landing, especially on wet runway surfaces. A major challenge in the Nigerian Air Force before now, with rectifying anti-skid related snags on the aircraft, was a lack of a test bench. Ideally, test benches are used to confirm the functionality of a system prior to installation on the aircraft. Towards resolving the anti-skid related challenge on the Alpha Jet aircraft, the Nigerian Air Force collaborated with some Nigerian academic institutions. Research persons from these institutions alongside their Nigerian Air Force counterparts have been able to successfully design and produce test benches for the anti-skid system of both versions of the Alpha Jet aircraft on the Nigerian Air Force inventory. The Air Force Research and Development Center has also designed and manufactured tow bar for the Alpha Jet aircraft for relocating aircraft within the flight line for ground operations and maintenance. The project was initiated because the new version of the Alpha Jet aircraft, which is currently deployed in the Northeast, has a longer nose section that made it incompatible with existing tow bars in the Nigerian Air Force, thereby making ground operations and maintenance activities cumbersome. The manufacture process involved the local sourcing of materials from within Kaduna metropolis, with the milling, cutting, shaping, welding and sanding process carried out at the center. Interestingly, a tow bar from abroad cost about $6,500 US, while the locally produced one cost $3,200, thus saving the Nigerian Air Force $3,300. The newly produced tow bar is currently being used at various Alpha Jets operational bases. One other recent feat achieved by the Nigerian Air Force in its research and development efforts is the successful manufacture of heat shield protective cone. The protective cone is used on fighter aircraft to reduce drag of rocket pods, thus enabling the aircraft to achieve higher speed. It also prevents rocket backblast from affecting other rockets in the rocket pod when fired. On the average, 40 of these protective cones are consumed in a week in the ongoing counter-insurgency operations in the Northeast. The protective cones were being imported at a rate of $1,250 for one, implying an average expenditure of $50,000 on a weekly basis. The Nigerian Air Force is now locally producing same quality of protective cone for $25, equivalent of 9,000 naira only, thereby saving the Nigerian Air Force a minimum of $1,225 per item. Considering the average rate of weekly consumption, this translates into savings of $49,000, about 17.64 million naira every week on the cones alone. Besides, the cones are now more easily available, as 20 units could be produced daily, thus enhancing Nigerian Air Force operational effectiveness. Similarly, the Nigerian Air Force designed and produced an unmanned ground vehicle following the unfortunate loss of a police sergeant who was in the process of defusing an improvised explosive device in Kaduna. The Nigerian Air Force subsequently received patent rights from the National Office for Technology Acquisition and Promotion for the production of UGVs, after design and manufacturing a more improved prototype known as UGV-2. The UGV is used to replace a human being in hazardous situations such as handling of IEDs and bomb disposal, while other military applications of the UGV include surveillance, reconnaissance, and target acquisition. Another feat is the design and production of 30.1mm rocket using locally sourced materials and propellants. The 30.1mm rocket was successfully tested during the 2017 NAF Day celebration in Makurdi. Since then, it has undergone several modifications to meet operational requirements, such as inclusion in the base defense architecture of the Nigerian Air Force. The live warhead, which was incorporated for this purpose, has been tested and found satisfactory in terms of fragmentation and blast characteristics. As further evidence of the ingenuity of Nigerian Air Force engineers and technicians, the ground-based and vehicle-mounted launchers for the 30.1mm rockets were also designed and constructed by Air Force Research and Development Center using locally sourced materials. The launchers were designed to pitch up and down to vary the launch elevation to meet desired launch and range parameters. The pitching of the launchers was achieved by means of a remote control operated from a safe distance. The cost of importing one rocket launcher is $29,700, which is considered exorbitant when compared to the sum of $9,200 expended to produce the same item locally, a cost savings of $20,500 per rocket launcher. Furthermore, the Air Force Research and Development Center has reactivated the unserviceable Air Force Matra 155 rocket launcher for the Alpha Jet aircraft at 103 Strike Group in Yola. The reactivated launcher has passed functional tests and are currently being used in Operation Lafia Dole Theater in the Northeast. The reactivation cost less than the equivalent of $800 as against $3,600 that would have been spent if the equipment was sent overseas for repairs, thereby saving the nation over $2,800. Another significant achievement was the local weaponization of the Alpha Jet aircraft, which were procured for the Nigerian Air Force prior to July 2015 without provisions for attachment of weapons. A Nigerian Air Force research team led by Mr. Armstrong Buba executed the successful weaponization, which included the installation of the DEFAC 553 gun. The project cost less than $1,000. A foreign company had earlier quoted $20,000 just to assess the aircraft for possibility of weaponizing them. The successful execution of the project therefore saved the nation about $19,000. The locally weaponized Alpha Jet aircraft has since then been contributing immensely to the ongoing fight against insurgency and other forms of criminality in the country. Mr. Buba and his team recently recorded another major feat when they weaponized the Bell 412 helicopter by adding the guns that were procured in the 1970s for installation on the decommissioned BO-105 helicopters. 2 pods comprising 2 guns each have already been installed on one of the 2 Bell 412 helicopters and successfully test fired, both on the ground and in the air. The Bell 412 helicopters were recently handed over to the Nigerian Air Force by the federal government. Through this research and development feat, the Nigerian Air Force has saved the nation considerable foreign exchange that would have otherwise been expended in purchasing and installing new guns. As part of the actions taken to further boost research and development, the Chief of the Air Staff, Air Marshal Sadique Abubakar, approved the reactivation of Machine Tools Workshop at the Nigerian Air Force Engineering Groups in Kaduna, Lagos and Makurdi. The workshop was adequately equipped at inception but had been abandoned and disused for upward of 25 years. The reactivation of this workshop, which was carried out in collaboration with the University of Maiduguri, has not only boosted aircraft maintenance capability but also enhanced the research capacity of the engineering groups. For instance, the 131 Engineering Group Makurdi used the facility to modify the battery card for the F-7NI fighter aircraft. Hitherto, the card always broke down after a year of use, thus requiring significant lead time to replace the batteries from overseas vendors. However, with the aid of a recently reactivated Machine Tools Workshop, the 131 Engineering Group Makurdi fabricated accessories for the cart, thereby reducing cost and downtime. The workshop has also facilitated the construction of a foreign object debris picker designed by the 131 Engineering Group for use in clearing all ferrous foreign object debris from the apron for enhanced safety. Similarly, the 631 Aircraft Maintenance Depot has used the recently reactivated Machine Tools Workshop in Lagos to produce an aircraft jack system for the C-130 Hercules aircraft, mostly from locally sourced materials. The C-130 Hercules weighs over 39,000 kilograms and requires 2 30-ton wing tripod jack and 12-ton fuselage tripod jack to lift the aircraft during maintenance activity. Significant energy and time are required to operate each manual pump on the jacks for even lifting of the aircraft to avoid structural failure that might occur if the aircraft is not evenly lifted. Besides the physical exertion required for their operation, The manual pumps are also prone to frequent failures. To mitigate these shortcomings, the depot used a workshop to produce the aircraft jacking system, which provides hydraulic power through a central control point to all 4 jacks. This has significantly reduced the time required to lift the aircraft, as well as the number of technicians required from a minimum of 10 to just 3 persons. It has also reduced the quantity of hydraulic fluid required by about 50%. Some additional research and development breakthroughs were showcased during the 47th convocation ceremony of the Nigerian Air Force Institute of Technology, Kaduna, which held on the 27th of July 2018. The projects include a prototype oleopneumatic shock observer for unmanned aerial vehicles. The shock observer was designed and produced by AFIT students using entirely locally sourced materials. The system has been comprehensively tested and would be used on UAVs that would be subsequently produced by the Nigerian Air Force. Furthermore, an automatic solar tracker was designed by AFIT students to maximize the harvest of solar energy, while a rocket launcher circuit text box was developed to test continuity in rocket launchers in aid of maintenance activities of Nigerian Air Force fighter aircraft. In addition, a multi-purpose unmanned helicopter was designed and constructed in-house by a team of AFIT staff and students led by Flight Lieutenant Nkemdilim Ofodili. It is a tactical unmanned aerial vehicle with range of 40 kilometers, endurance of 30 minutes, and maximum altitude of 400 meters. It could be used for both military and surveillance applications such as area surveillance, mapping, policing operations, pipeline monitoring, among others. Over 70% of the structural work on the helicopter was done in AFIT, while the flight control and autonomous navigation system were entirely indigenous developed. The foregoing are just a few out of the recent achievements of the Nigerian Air Force in research and development. The outcomes of other ongoing research efforts would be unveiled in due course. Although the Nigerian Air Force is yet to attain the desired level of technological progress, it is taking the right steps in the right direction by innovating towards enhancing its operational effectiveness. The interesting development is that at the heart of these novel steps are resource persons from the Nigerian academic and research institutions working in concert with the Nigerian Air Force personnel. With the continuing support of the federal government administration under the leadership of President Muhammadu Buhari, the Nigerian Air Force shall surely attain its objective of technological self-reliance in the nearest future. What is required now is private sector participation towards mass producing the Segome UAV and indeed other research and development products of the Nigerian Air Force as part of efforts at improving Nigeria's technological base, also further enhancing the operational effectiveness of the Nigerian Air Force.